Good morning, students. We have learned how to calculate the field density of the soil using sand replacement method and core cutter method. In this video, we will discuss about how to determine field density of soil by Troxler NDG, where NDG stands for Nuclear Density Gauge. The scope of this test method describes the procedure for determining the in-place density and moisture of earthwork through the use of a nuclear gauge. The density and moisture of the material shall be determined by direct transmission. This method may be used in conjunction with either the standard or modified Proctor test. Here in this picture we can see the assembly of the gauge. There are currently 5 gauge manufacturers which collectively have more than 20 different gauge models that measure soil, asphalt, concrete density and soil and roof top moisture. We can see in the picture the gauge have a source rod that lowers into the ground to measure wet density and another stationary source contained in the base of the gauge that measures moisture. The radioactive source that measures the density is located at the base of the source rod. The actual radioactive material is fused into a dry pellet about the size of pebble. The pellet is encapsulated in 2 laser fused metal cells that in essence create a solid piece of material that is virtually impenetrable. This Geiger-Müller tube embedded in the base of the other end of the gauge detects the gamma radiation that is emitted from the radioactive pellet and passes through the material under the gauge. So we can see here, this is handle, this is depth rod, source rod, key path, and these are the tungsten sliding block. So this is source rod, and all these things are arranged in a casing. Remember that radiation is always being emitted from the gauge. These are the equipments to perform the Troxler NDG, that is portable nuclear moisture density gauge, transport case, charger, reference standard block, transport documents, labeling plate or drill rod guide, drill rod extraction tool, hammer used for driving the pin, safety glasses, square point shovel, number 4 sieve, set balance scale, drawing apparatus, and miscellaneous tools such as mixing pans and spoons. Before actual test, we have to prepare the site. So we have to remove all loose and disturbed material and additional material as necessary to expose the true surface of the material to be tested. Prepare an area sufficient in size to accommodate the gauge by grading or scraping the area to a smooth condition so as to obtain maximum contact between the gauge and material being tested. The depth of the maximum void beneath the gauge shall not exceed 3 mm. The placement of the gauge on the surface of the material to be tested is critical to accurate density measurements. The optimum condition is total contact between the bottom surface of the gauge and the surface of the material being tested. The total area filled should not exceed approximately 10% of the bottom area of the gauge. Turn on and allow the gauge to stabilize according to the manufacturer's recommendation. Before the actual test, we have some predetermined information in hand which may act as an input for the analysis or for the result of the NDG test. These are date and time, target value, that is Proctor, results from the Proctor test, test length typically 1 minute, project number and offset. Let us come to the actual procedure. There are two basic models of using a gauge to determine density of soil or asphalt. The direct transmission procedure or method is used for soil and aggregate, while the backscatter density method is generally used only on asphalt. Here we will discuss only the direct transmission method to find out the in-place density of the soil and the moisture content. The direct transmission method consists of drilling a hole in the material, lowering the source rod to a specified depth and counting the amount of radiation that is able to pass through the material to the detector tube. The gauge works by counting the radiation that is received over a given period of time, usually 1 minute. So let us discuss the stepwise procedure. Select a test location where the gauge in the test position will be at least 150 mm, that is 6 inch, away from any vertical projection. Make a hole as shown in the figure. Make a hole perpendicular to the prepared surface using the rod guide and drive pin. The hole should be a minimum of 50 mm deeper than the desired measurement depth and of an alignment that is that insertion of the probe will not cause the gauge to tilt from the plane of the prepared area. Mark the test area to allow the placement of the gauge over the test site and to align the probe to the hole. Here we can see in the figure. Then remove the hole forming device carefully to prevent the distortion of the hole, damage to the surface or loose material to fall into the hole. Here in this picture we can see the hole and here the hole forming device. Now place the gauge on the material to be tested. Ensuring maximum surface control as described previously. Lower the probe into the hole to the desired test so that the back side of the probe is in intimate contact with the side of the hole in the gamma measurement path. Keep all other radioactive source at least 9 meters, that is 30 feet away from the gauge to avoid any effect on the measurement. If the gauge is so equipped, set the depth selector to the same depth as the probe. Now secure and record one or more 1 minute density and water content reading. Read the in-place weight density directly or determine one by use of the calibration curve or table previously established. Read the water content directly or determine the water content by use of the calibration curve or table previously established. Here we can see in the display we have different buttons, so it will give automatically the different like water content, then dry density, all these things. So we can use this method to calculate the density, or we can say in place density or field density of the soil and moisture content. And once the moisture content is known, we can directly calculate the dry unit weight of the soil. This is a very sophisticated method normally used in the other country, developed or developing country. In India we usually use core cutter method and sand replacement method. So it is one of the very useful method to calculate this. So I hope it is clear to you how to use this Troxler NDG method to find out the in-field density of the soil and moisture content. So thanks for watching. Don't forget to subscribe, like, comment, share, and share also this video. Thank you.